Okay, so my last video ended, and so we're going to have to pick up where we left off. So we were talking about carbon dioxide here, and so carbon has 4, oxygen has 6 times 2, that's 12, so I have 16. All right, so carbon in the middle, oxygen and oxygen. We're going to do a single bond, and that gives me 4 off, so I'm down to 12. So if I put dots on each of these oxygens, I believe that's where we kind of left off before I realized that I was running out of time. We have a little bit of a dilemma here, okay? So I can't just be done here because carbon is currently not satisfied, but the oxygens are. And I have completely run out of my electrons. So what happens in this situation is we have to take 2 of my electrons from the oxygen and share it with carbon here. So once again, if I didn't have enough, I'm going to have to share extras, and the same thing on the other side. So we're going to take away 2 from this oxygen. Come on. And we're going to put it into the bonds here. All right, and so what that does is it now gives carbon its octet, and I haven't changed the number of electrons overall. Okay, I still have 2, 4, 6, 8, 10, 12, 14, 16 total, which is what I had to work with from the beginning. Okay, so that one is all done. Our next one is C2H4. So we actually have 2 central atoms this time. We have 2 carbons. And what I'm going to do here is I'm going to split my hydrogens. So here, 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 and here. I got to get my count. Carbon is 4 times 2, so that's 8 total. And my hydrogens are 1 each, and there's 4. So that makes 12. I'm going to put a single bond between everybody. 1, 2, 3, 4, 5 bonds. And that's 2, 4, 6, 8, 10 electrons. So that's 10 here. So I'm down to 2. All right, so each carbon has 1, 2, 3 bonds, and so that's 6 electrons around this one, 6 around this one. Remember, our hydrogens just needed the 1 bond. So since I've got 2 more to place and both carbons need another pair, they're going to share that pair. And so there will actually be no lone pairs in this one, and both carbons will be satisfied with 2, 4, 6, 8 and 2, 4, 6, 8. All right, so here's a challenge question for you. So if you want to try it, go ahead and pause, and then we'll try it together. So what's happening here is this is a polyatomic. This is our polyatomic hydroxide, okay? We know that oxygen contributes 6 and hydrogen contributes 1. But what this little guy means, remember, this means add 1 more electron. Okay, so we add 1 more electron and we end up with 8 total. All right, so that's what that means to us. So we're going to put oxygen next to hydrogen. We're going to give them 1 bond, and that's going to take care of hydrogen. So now we're down to 6. But oxygen's not satisfied, so we're going to go 2, 4, 6, like that. Now, because it's a polyatomic ion, remember, it gets a bracket and a -1 charge on the outside, just like we did for our ions in the ionic unit. But this one is going to be charged here because remember, oxygen didn't have enough for it to do this. We had to add an extra one in, and that's where that number comes from. It's the extra that we don't need, or that we didn't have to be able to satisfy this. I just made it ugly, sorry. All right, so this is my extra from the charge. All right, And so that's a little extra one and a little challenge question for you. Okay, so that is all we have for the notes for today. You're all done, but I do want to go to the actual worksheet packet, and I want to make sure you've covered everything. So you should have gotten through all of these notes here, and then all of these example questions. All of that should be filled in. And then if you will go down to page 14, this is where we're going to be staying for the rest of class. So you've got the rest of class to work on this. You're working on 14 through 17, okay? So what I specifically want you to work on, okay, is I want you to name them for practice. I want you to draw them, which is what we've been doing. I want you to count the lone pairs, the number of single, double, and triple bonds, okay? We will do Vesper shapes another day. We will do bond and molecular polarity another day. So these two columns, the drawing is really the only main new thing that you have. And then counting your lone pairs and single and double, triple bonds. That